at some point. Number 2, dot product formula. Multiply the horizontals, multiply the verticals, add. Number. Number 4, orthogonal. That means perpendicular, and the dot product equals? Not yet. 0. Oh dear. Number 12. How many of you guys rewrote, I'm just curious, how many of you guys rewrote those in side carets to be able to do it? That's it? Like 3 or 4? Okay. So, well, some of you just took the i's and j's and said 21 minus 8, but I was just curious, because for some it is easier to write the side carets and see the numbers. Anyway, final dot product 13. Number 54. Ooh, this was interesting. We talked about orthogonal, and the dot product was not 0, so it's not orthogonal, but how could you figure out parallel? Parallel means same slope, yeah?
Yeah.
Same slope, which means same direction, but different length, possibly? So what they're saying, which we haven't explicitly written in our notes, so you might have had to think outside the box. Ooh, critical thinking a little bit. Debates help with that too. Anyway, they should help with that. I'm not sure they do. Some people just pick an opinion and go with it passionately, even if they have no evidence to back it up. Anyway, but, coming back, or haven't thought about anyone else besides themselves in the argument, but coming back, I was talking about debates in general, not you guys specifically, but that's okay. Critical thinking, parallel. I need them to be scalar multiples of each other. This 3 and 15, does it relate to 1 and 5? Seems to, doesn't it? 3 is to 15 as 1 is to 5. It sure sounds like they are related. If I was to go over 3 up 15 and over 1 up 5, guess what's going to happen with their slopes?
Same.
They're the same. Ooh. So why did this say not parallel? What did I do wrong? It should have been a negative 1. And what's going to happen if 1 is negative and the other one's not? Ooh, that's not parallel. They're going to intersect, right? But if it was a positive 1, positive 5, guess what would have been true? It would have been parallel. Okay, anyway, parallel, something new. But if you had drawn the 2 vectors, you could have looked at them and been like, haha, no. So, number 76 is tiny. Can we see it? How rough was he? Was he rough because there were words or because the math was hard?
No, because I think it's just
Oh dear. I swear you guys read words in other classes and don't freak out. Maybe you do.
Yeah.
So you walk into English and you're like 1, 2, 3, freak out?
You do too.
Question, do we have any other? No, we don't. All right.
I got lucky.
Thank you for not being asleep, but shush. So, number 76, I am bringing it up really quickly, but as I do that, guys, this is our last even. Can I hear from you guys if there are any other questions on homework besides 76? Yeah.
79.
Okay, so we don't like the 70s. Any other ones? Okay, let's go peek at 76 and 79 real quick and try to figure out the math to it and not be deterred by the words. Ooh, deterred, good word. Chapter 6, section, okay, let's try this again. Chapter 6, section 4, right? Okay. Why? Every time there's a page of word problems, it just doesn't like it. And then look, all of a sudden it's going to be happy. Okay, well, that's fun. Forget the book. It's not going to be helpful. All right, number 76. What did they give you?
They gave us an angle of elevation. They gave us the weight of the object.
Oh.
No,
Okay, so that's not that different than what we did in class, right, guys? Technically? Okay, so they gave an angle of elevation, number 76. What was the situation? Was there like a thing on a hill? Was there like a
Car.
sport
utility.
utility?
Car.
On a hill.
It's a car. No, it's a sport utility.
I drawing? I don't even know. Okay, there's a car. It didn't work out so well. I'm drawing like my cool car from when I was in elementary school. This is the one I would draw all the time. So it was like a rocket car. And then it had like the exhaust coming out, and then it had like fire on it, and then it had like a bubble top, and then it had like anyway, so I know exactly, it's a rocket car.
That's like,
Oh, that's pretty cool.
I
Alright,
like it, it's supposed to make it fun.
now what?
Rocket car to a
30?
No, 10.
It was definitely 10. Definitely. I did not
Oh.
76 goals.
Everyone took that white.
No, 10.
It's 10.
I'm done. Alright, you guys said that, I'm sorry. What else did it tell me?
The force of gravity is 5,400. Yeah, that's the same.
Is it one of these guys? What's it asking for?
The force perpendicular.
Find the force required to keep the vehicle from rolling down the hill.
Okay, so long story short, you have this triangle, or you have this straight down being the gravity, you have this being, like if something was moving it up or down, and then you have this one being the perpendicular. So that's our perpendicular force, because it's perpendicular to the object. This is our gravity, so 5,400. And then where can we put the incline? Right inside. Ta-da! So how do we solve? Well, I don't know. There's the hypotenuse, and that's an adjacent. Cosine. So it's easy as cosine of 10 degrees, not 30. How do we even get 30? Is equal to x over... Oh. It's okay. Dun 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 dun. That was 76?
Did you find
Oh. How did that sound so nasty?
did you find that earlier too?
Wait, did it ask for work?
It said find the force required to keep the vehicle from rolling down the hill.
Oh. So it didn't ask for the perpendicular?
It asked for both.
It says find force perpendicular to
Yeah, but
But then it also says...
force that kept it from rolling down.
Notice come to see the.
Is that two different answers?
Yeah, it should be two different answers because it's two different sides. First of all, check the cosine one. They're doing it with the projection. I didn't even think of doing it with the projection. I was just using my triangle. What ended up happening when you did the 5,400 times cosine of 10? Perpendicular, yeah. 5,300, 17.9, and they must have said round to the nearest pound or something like that. So that'd be 5,318. Okay, so that works. We just did it in a different order than they did. We just did it in a different order. So we found this is the perpendicular force. But what else were they asking? The force that kept it from rolling down the hill? They want this guy. So kiddos, the cool thing is, perpendicular, I mean this is a right triangle, so if we have two sides, how do we find the third? Pythagorean theorem, right? So y is equal to the square root of 5,400 squared minus x squared. Plug it all in nice and not rounded. So then the square root of 5,400 squared minus this guy squared 937.7, but did they say round to the nearest whole? Here, I'll just put this and we'll go look at it. But that would be the force to keep from rolling down the hill. They rounded it to, oh no, they did that, 937.7 pounds. Okay, that wasn't too bad. The book just made it way worse with projections. Anyway. Oh, 79, sorry, that's an even, that's not an even, that's an odd. Alright, John, let me know what's going on 79. I'm a little blind.
I might have not attempted it.
Oh.
Boy.
Anybody who attempted it have a question?
Oh.
And you can tell me what it was?
Angle of 30, and then on the like slope up.
Something on a slope, okay. What else?
It was 45
It's
pounds.
the bottom.
And then it has like down below is distance.
The word done in sliding is 20.
Oh, okay.
No, that's its distance, I thought.
Yeah.
Oh, that's distance? So it's being slid along the hill?
Yeah.
Ooh.
The box is like below it, and it's like a rope on you.
So this is the box,
Yeah.
moving, got it. And this is like a little guy with a rope who's trying to like pull it or
Yeah.
something. He's like, yay, I'm trying to pull. Okay, so 20 is how far? 20 miles, feet, meters, feet? And then how much does the box weigh?
45 pounds.
And that's not the tension on the rope, right? That's the weight of the box?
No, I thought it was
Force, a force of 45 pounds exerted.
Exerted. Oh, that's not the weight of the box.
I see.
That's how hard this guy's working.
Thank you, Dana.
Thank you. So the force exerted is 45?
It says 5 words.
Okay.
Don't you just multiply
So the-
everything?
Well, the force exerted would be the magnitude of this vector, right?
Yeah.
I need to do work equals, I'm guessing it's a work problem, right?
Yeah.
Force times distance, but I don't want the magnitude of the force. I need the dot product. Distance, I could say the distance vector. Did anybody figure out how to put that in components?
20.
Yeah, 20 is horizontal, and it moves vertically none. And then how can I make the force in line with the distance of movement? How can I make that a vector?
That is 45 sine.
Careful, the horizontal is cosine. So 45 cosine of 30, and then 45 sine of 30. That's how I get my vector in the right direction, not the diagonal one, but the one in line with. And now just a dot product. Yeah?
Yeah.
Yeah.
So the dot product would just be, wouldn't the vertical times vertical just be 0?
Yeah.
So my dot product, the work is just going to equal 20 times the 45 cosine of 30 plus 0. Does that kind of make sense? Okay. It was really similar to the box one we were doing. You just have to make sure that you understand what they're labeling. So the force was the magnitude, the 30 was the angle, so I can make a quick component form of the force that I need to use, not the force exerted on the rope, but the force that's going to, or the projection of that force in line with the box's movement, and then just dot product. Cool beans, that's 6-4. Kiddos, whew, we gotta go in 6-5. Remember? We're supposed to finish him today. So let me go ahead and get out of this homework. Let's get into notes. We started him yesterday. I think we got this all down yesterday, right? Magnitude of a complex number? I think we got this down. Kiddos, I was able to finish getting points of your corrections onto your test scores. So the TA, Eileen's going to record them when she comes back. And then I'll try to update that in RenWeb, hopefully today. Although, I will be in the gym for the majority of tonight because what's going on? Village games. You guys should come out and support girls and guys. Or girls just get left behind. Who's playing at home, guys or girls? Both? The soccer?
No.
It's always one.
Girls soccer doesn't have a team this year for village.
Oh yeah, we play.
The village girls. We have.
They don't-
Yeah.
You serious?
Yeah.
Any sports are just going out.
Oh, no,
Well, they're bringing back their football teams.
Wait, they're girls?
The guy who's football director.
Oh,
The guy who's football director. I don't know. He's from like some team that actually 6 years ago.
Yes, we have this page.
Yes, ma'am.
Good. I don't know why that was a PS. I was trying to get your attention. We have this page.
Oh.
Ah, here we go.
Time
Fill
ago.
in. Beep, beep.
Oh, I'm so sorry.
My main point yesterday was to say, why on earth are we covering this section right now when we've been doing vectors and triangles and real geometry like figures and physics with forces and why complex numbers? A lot of the math is the same. A lot of the formulas work the same. So, we talked about yesterday magnitude of a complex number. It's Pythagorean theorem with the real a and then the imaginary coefficient b. But still just square root of a squared plus b squared, like the magnitude of a vector. This page is to say, hey, if we know r and theta, if we know the magnitude and the angle of the complex number, we can get the components a and b, the real and imaginary, or if we know the a and b, we can get the magnitude, Pythagorean theorem, or the direction with tangent inverse. And so I barely got to show you, barely, the trigonometric form, which is new. Standard forms, that's old school. We covered it in chapter 4, 3, 2, I don't know. We covered imaginary numbers back in the day. Let's put it that way. Last semester sometime. And so standard form, a plus bi, we're kind of used to. We added imaginary, I should say complex numbers, we subtracted them, we multiplied them. Ooh, I squared is equal to -1. We divided them, ooh, multiply top and bottom by I, or multiply top and bottom by the conjugate to simplify. But we did not deal with complex numbers in trig form, which looks a lot like vectors with components. Magnitude cosine theta, magnitude sine theta, the little I is there because he has to be there. It's a complex number. He needs the imaginary guy. And so to finish off 6-5 today, we're just going to play with complex numbers and realize there are a few properties that will help us deal with them in whatever form they come. Trig form or standard form. And as you guys look at the examples and write them down, one is clearly, hopefully clearly standard form, number 13, and one is clearly trig form, number 13. Number 13, number 32. He asked Chick-fil-A tomorrow 5 to 8. It's an excuse to get Chick-fil-A. Be like, Mom, it's really good. If you're like, oh, I have life groups or D groups, which is a good thing, so don't say, but be like, oh, we'll go first. I'll invite all my friends to come. Go team. Exactly. You can be like the life of the party. Get chicken nuggets for everybody.
No, everybody needs to stay your food.
Okay, then you're on the way.
Ruin it?
No. That's how I
Start to like what?
Chick-fil-A is not meant to share.
See? Plenty of time for dinner.
Yeah, he doesn't want to go to Costco before that. We actually should go. I don't have any, so I'll wait.
Get Chick-fil-A for your life group leader and be a hero.
He doesn't spend time in Costco.
10:50.
He's too busy.
Exactly.
He's in Vegas all the time now. Whatever I see him, he's always the same.
That's why they're motivation.
I don't know.
Alright, well on that note, let's
I'm being honest, he's like, whenever I see him, we're like,
Hey, honesty is the best policy.
he's always in Vegas.
With discretion, but
All his friends are getting married, that's why he keeps going to Vegas.
Yeah, most times
They all get married in Vegas.
like someone
guys, there is one other way of writing this. It's basically for lazy people. And it was in another pre-cal book. It's actually not in this one, I don't think, but you could write it r cis theta. I know it looks weird, but cis theta would be cosine theta plus I sine theta. It's just a shortcut. So the r is there, the theta is there. It's a shortcut for this. Anyway, you might see that. I don't know. Probably not in our book.
I hope so. What's this?
Oh my goodness. Anyway, coming back. If we look at this guy, I just said he looks an awful lot like standard form, right? AKA there's no theta, no cosine, no sine. He's standard form. How could I get him in trig form? Well, I need an r, and I need a theta. How do we find an r and how do we find a theta? If we think about this complex number in terms of its components, its real and imaginary
X and Y.
coefficients. Yeah, think of that as x, think of that as y, and how do I find r? Pythagorean theorem, 1 squared plus negative root 3 squared, which ends up being, ooh, mental mathers, anybody get 2? 1 plus, rad 9 would be just 3, or square root squared. Negative times negative is a positive, so 4 square rooted is 2. Now how do I find theta? Magnitude or the r is pretty simple if you remember Pythagorean theorem using a and b. How do I find theta though?
Inverse tangent.
Inverse tangent.
Negative rad 3 over 1.
Good. Of b, over A. Now you could be super snazzy and say, that's the unit circle. Square root of 3 over 3, 1 square root of 3. It's a 60 degree.
What?
It's never that easy.
I didn't see your chart. The tangent row. It goes square root of 3 over 3, 1 square root of 3. And I've changed keys. But square root of 3 goes with 30, 45, 60. The third one, 60 degrees. But it's negative. Ah.
Oh, no.
So it's negative 60 or negative pi over 3, right?
No. It's simple.
Don't we say with tangent inverse, we gotta check to make sure we have the right guy? Because tangent inverse only gets us one answer when there are infinitely many. So how could I tell what this guy needs? Can't I graph 1 and negative, I don't know, rad 3? What angle do I need? Fourth quadrant, right? Oh, and what's negative pi over 3? Fourth quadrant, sweet. So I'm done. If you want to write it the lazy way, you could go ahead and say z is equal to 2 cis, bless you, negative pi over 3. You could also write it the positive way if you really like, couldn't you? Couldn't you write it positive 5 pi over 3? That took me way too long, I apologize.
Yeah.
Or you could write it the super snazzy 2 times cosine of, I'll use the other angle just for sake of argument, plus I sine of, so you could use the cis notation, you could use the negative pi over 3. I think for complex numbers, they almost always put a positive angle, so that's probably the one to be on the lookout for. But technically it's the same location, so I guess it's all right. Now, are we supposed to go to the unit circle and plug in? No. What? Why? If we did, we'd end up right back there. This is the simplified one, and this is the expanded. Hey, you can see r and theta. So how about number 32, when we have the r cosine theta, I sine theta? Eileen, just draw me a quick little update on that column.
Oh, yeah.
Does that make sense?
Yeah.
Hero, she's got me. Number 32, how do we write the standard form? Condense it. Simplify it. What we shouldn't and didn't do in the one before, do it now. Don't do it. Sorry, I passed the pirate. No. Patch the Pirate's like a kids program made by Christians, like a radio program kind of thing. Teaches good morals. So there's a song that says, do it now, don't delay, don't put it off till another day. Go ahead and do it. No, go ahead and do it.
should have watched it.
Right this very minute, you better do it now.
I bet you I would have procrastinated to last
Patch the Pirate? Yes, tonight. Much more beneficial than most of the shows that we, including me, watch. All right, so.
What if I watch a Christian show?
I said much more beneficial than most. I did read more qualifier. Okay. Hey, I use God is bigger a lot. VeggieTales, that's good stuff too. That's some weird stuff.
You were racist.
Not sure the lip songs are really that helpful or sanctifying. But anyway, 135. So,
I feel like that's beneficial.
it's like the second time. At least it's mostly clean.
First episode.
Pretty fun.
Worst.
There's some creepy ones though. There's also like Friday the 13th.
That was funny. Tuesday the 7th.
It's like, this is 135, right? Kiddos, isn't that a 45 degree in the second quadrant?
Yeah.
When sine is positive and cosine is negative? And they both equal root 2 over 2? Dun, 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 dun. It's a 45 degree in the second quadrant. Both sine and cosine are square root of 2 over 2. All students, sine is positive, cosine is negative. So all I had to do was take the cosine and multiply it by 5, and then take the sine and multiply it by 5. Done. There's A, there's B.
Wait, why is it negative?
Ah, because cosine is negative and sine is positive. Okay? It's a 45 in the second quadrant.
What if you get a decimal, put a decimal instead of 345?
I guess it's not awful, just be prepared that if it's unit circle, I still expect you to have it memorized in case there wasn't a graphing calculator. Carl,
Can you go to the graph really fast, please?
this one?
No, the very top.
Oh, you mean the formula? Got it. Colby,
If we put 2.5 square root 2, would that be okay?
yeah, that'd be okay. As long as you could make it match with, like, say, a multiple choice answer that has the other form, but yeah, that's okay. Okay, so with this, that's just transforming from standard to trig, or from trig to standard. So what if, Carl, do you need a picture before I change it, or are you okay?
Thank you.
Okay, you're welcome. Whew, let's do some stuff. Let's do some stuff. If we were, wait, hold on, if we were to add complex numbers in standard form, wouldn't we just add the reals and add the imaginaries? Done? Exactly. The problem is trig form, it's not so easy, but there are patterns. Trig form, not so easy. Component form is almost always better. Trig form though, not impossible, just not so easy. What patterns, as you guys are writing, given complex number z1 and complex number z2, with different r's and different thetas, what's the pattern that you see with the multiplication and division? With the multiplication and division.
It's the same formula, just different signs.
Yeah, yeah, the formulas are super similar. And the nice thing is, guys, what happens to the radii every time, or the magnitudes every time? They mimic, right? So multiply the complex numbers, cool, multiply the radii, or the r's. Divide the complex numbers, cool, divide the r's. What gets funny? The trig inside. And basically, what's going on is that if you were to add this the long way, of multiplying the r out, combining the horizontals and the verticals, I should say combining the real and the imaginary, you would be able to simplify it to the composite argument, sorry, you guys call it the sum and difference formulas. You can condense it into the sum and difference formulas. I'm not going to make you do that, let's just jump ahead and say, sweet. When multiplying two complex numbers, multiply the r's, add the thetas. When dividing, divide the r's, subtract the thetas. So when we get down to something like number 45 that looks super nasty, and to actually solve, you'd have to multiply the 2 and the 6 and then FOIL the binomials, FOIL the complex numbers. It's like, it's going to end up being this thing up here, so just use it. Oh, okay. So how do I just use it? I say 2 times 6 is 12. Multiply the r's. After foiling and simplifying and using all those properties from chapter 5, it's going to end up being a, sorry, I keep calling it composite argument. That was another pre-calc book. It's going to end up being a sum formula, cosine A plus B plus I sine of, I should say, that's not a sine. A plus B, or U plus V, or theta 1 plus theta 2. And this helps us avoid the whole actually needing to FOIL out and simplify all the stuff up above. It's going to end up being this. Let's just jump there. So I'm using the formula right here. The multiplication way, multiply the r's, add the thetas in the trig form, and then simplify. So what's 1/4 plus 1/12? Common denominators. Multiply 1/4 by 3 over 3, right? Anybody else getting 4/12? And 4/12 reduces to be 1/3. Could we simplify to standard form? We could, but what did it say about leaving the answer in? Trig form. So we're going to leave it in the cosine, I should say. And the new r, cosine of the new theta plus I sine of the new theta.
What
You guys see how I simplified using the formula? Multiply the r's and add the thetas. Multiply the r's, add the thetas. Done. So you guys go do 54 using the quotient property. What is on my board right now? What'd you guys do to the r's? Good, so 5/4, right? What'd you do to the thetas?
Subtract.
Exactly, and what's 4.3 minus 2.1?
2.2.
Is it really that easy? And the answer is?
Yes.
Yeah.
Except for when it's the test.
So what does that mean you need to do with the formulas before?
Remember how to use those.
Study hard.
There's a lot to
A lot of formulas, but a lot of patterns. A lot of formulas, but a lot of patterns. Last one. Last one. And this one only gets super weird. Just a quick warning. This one gets super weird with fractional powers. But as long as it's not a fractional, as long as it's, I should say, powers that are in between 0 and 1. Like roots, like radicals. Those ones get nasty. But any power that's above 1 is pretty straightforward. Just follow the formula. Now I'm going to show you, as you guys are writing this down, I'll show you where this formula comes from. The other one would have been a little bit longer, so I was saving time. I'll show you where this one comes from, just so that you realize these aren't just coming from nowhere. They're just the simplified form of what you would have to do. It's a simplified formula, shortcut if you want to say, of what you would have to do if given this problem. If I was squaring a complex number in trig form, I'd have to rewrite it and then multiply it. R times R would be R squared. Wait a minute. Couldn't I use the multiplication property from the page before?
Sure.
I'm multiplying two complex numbers. So it's going to be R squared, and then what's going to end up happening after I FOIL to my thetas?
Cosine squared.
Well, not cosine. Well, when I FOIL, it would be cosine squared theta plus I squared sine squared theta plus 2 cosine sine theta times I. I'd have to simplify. It would get messy. But what ends up happening? What's your multiplication property say? Multiply the r's and add the theta. So I could just say cosine 2 theta plus I sine 2 theta. After you FOIL, you're going to end up with the double angle of sine formula and the double angle of cosine formula. So we skip ahead and say, oh, hey. And what do you guys notice right down here? What's its shortcut to even having to think about it as a multiplication of 2? Say, what ends up happening to the r? Yeah. So what's going to always end up happening to the r is that it's raised to the nth power. And what's always going to end up with the cosines and the sines after FOILing and simplifying with properties? N theta, N theta. This time it was squared, so 2 theta. If it was cubed, 3 theta. If it was to the 4th, 4 theta, etc. So I'm looking at this guy down below. What's going to end up happening if we raise 3 cosine 60 plus I sine 60 to the 4th power? 3 is going to get raised to the 4th power.
81.
Careful. 4 times. Oh, you did 81 is 3 to the 4th. Got it, Colby. Sorry. I was already in here to the angle. So it's going to be 60 times 4. So 240. Plus I sine of. And yes, Colby was right. 3 to the 4th is 3 squared 9 times 3 squared 9 is 81. So it is going to end up being 81 cosine of 240 plus I sine 2. Wait. That's trig form. What do the directions say? Standard form. Okay. We got it. Is 240 a unit circle one? It is, right? 240's in the third quadrant, 30 degrees away from 270, which will be the same thing as 4 pi over 3.
Oh, yeah, we did degrees.
It's a standard form. Sorry, we could leave it in degrees, 240. My brain just does radians more readily because that's what HPrecalc does more often. We're going to have 81 times, what's cosine down there? Negative, right? And cosine is over a little, so negative 1/2. Plus, sine is negative also, down a lot. Anybody else at negative 3 pi over 2? Sorry, negative root 3 over 2. Last but not least, bring in the 81. Negative 81 over 2 minus 81 divided 3 over 2. Is that okay? Okay. So I said Demois, ooh, I didn't even tell you guys his name, Demoivres? Someone in French, say it a little bit better than me?
Embroidery.
I'm not sure you're in
I'm not in French.
Who's in French? Somebody's done in French.
There you go.
Not anymore. No. Tapping out, party pooper, all right. Anyway, something to do with Demoivres. Anyway, Demoivres theorem only gets weird. Demoivres theorem only gets weird when we have to deal with roots. And you're like, wait. Why does a root even compare? Look. Down here. We're trying to find the nth root of, oh, that's nasty. I don't know where the root went, sorry. We're trying to find the nth root of a complex number. Remember that the roots are the same as fractional powers? And so if I have the nth root of z, it's the same thing as z to the 1 over nth power. Remember I told you this only gets weird when we have a power that's less than 1, but greater than 0. Less than 1, but greater than 0. Because technically, a root can be seen as a power. So I could use the original Demoivres theorem. And I would get cosine of 1 over n times theta plus I sine of 1 over n times theta. That's just using Demoivres theorem from the page before. I'm saying, okay, whatever the power is, I raise r to that power and I multiply the theta by the power. And you're like, okay, cool. So to find the nth root of z, plug it into Demoivres theorem. But do you guys remember the multiple angle equations? When we had something nasty like cosine of 3x equals 1, what did we have to be careful of when solving this guy? Let's say that we were solving between 0 and 2 pi. Do we divide by 3 first, or do we deal with the cosine first?
Cosine.
So I have to think of cosine inverse of both sides, which would get rid of the cosine. Cosine inverse of 1, well, isn't cosine 1 at 0? Well, it's negative 1 at pi, that's not good. 2 pi, 4 pi. Why am I writing so many? Because we're about to divide by 3. And when we divide by 3, what normally would have been outside the bounds ends up being inside the bounds. When do I stop? Right there. So there are more angles that get included because of the 3x. It takes a broader range and reins it in. Guess what's happening when I multiply a theta by 1 over n? The exact same. I have to include more because when I multiply by the 1 over n, I'm taking angles that would have been outside the 1 revolution, saying, no, come here. You're good too, because when I divide you by, you'll fit up until a certain point. And the crazy thing is, what I told you guys was a hint over here that if you have a 3x, you'll have 3 times as many answers as normal. When you have a 6x, you'll have 6 times as many answers as normal, etc. Same thing here. If it's a square root 1/2, you're gonna have twice as many answers as possible. If you have a 1/3 root, you're gonna have 3 times as many answers as normal, I should say, et cetera, et cetera. So let's go ahead and try to use it, because I think you guys have gotten the formula almost by now.
Yeah.
But what this is saying is, okay, you're gonna have, starting at 0, which is a little weird. If I stopped at n-1, let's say it was a cubed root, that'd be a 1/3. I would stop at 2, because that would give me 3 answers. If it was a 6th root, I would stop at 5, 1 less than the root, because that would give me the 6 answers. So with this guy, oh no, wrong way. I'm sorry, Carl. I asked if everyone was finished, and all I heard was a yes. You gotta speak up, but or else I don't know. Take a picture of it. Remember, group members, supposedly they have it, and they're right next to you. Cube roots. Cube roots. Wait a minute. He's not in trig form. Now I'm going to cheat just a little bit for sake of time. If my A is 1 and my B, oh no, it's positive actually. Is there anything special about the triangle with a 1 right here and a rad 3 right here and a 2 right there? Yeah, it's a 30-60. Specifically, what is it if the big one is here? Is it a 30 or a 60?
60.
Okay, so I could cheat just a little bit and say, hey, I know who that is. Could you also do R cosine theta, R sine theta? That doesn't work, I have components. Could I do Pythagorean theorem to find R? And could I do tangent inverse of B over A? You would still get to 60 degrees. The only struggle is, hold on. Do you guys see I could rewrite this? Just check it. I could rewrite this as negative 125 times 1/2 plus root 3 over 2 I. Do you see your cosine theta, sine theta? So if I bring the 1/2 in, all of a sudden I have my sine and cosine the way I want. Wait a minute, R is never negative. Struggle, what quadrant am I supposed to be in? It's a negative and a negative. I'm actually supposed to be in the 3rd quadrant. So my angle is going to be 240 or 4 pi over 3. Anyway, you can use the formulas. I'm just kind of trying to get you guys to where they're a little bit faster. R is our 125. We have cosine of 240 plus I sine of 240. I'm doing degrees because that's what our book has been doing in this section, so I'll skip it in degrees. But what am I supposed to be doing to this guy? Cube rooting him. So I'm supposed to do the cubed root of this guy, which would be this guy to the 1/3 power. So I cube root the 125, and what do I do to the angles?
Divide by 3.
Divide by 3 or multiply by 1/3. No. Oh, maybe I should have kept it in radians. We'll keep it in degrees. I know because of the cubed root, I'm supposed to have 3 answers. If anybody hasn't figured it out, the cubed root of 125 is 5. 5 cubed is 125. I'm going to end up with 5 times cosine of 240 over 3 is 80. As long as I divide both, it's legal. 360 over 3 is 120. Okay. 80 plus 120. Okay. And now we just have to say, well, we need 3 answers. Start when k is 0. So we get 5. I'm just going to use my shortcut notation. Cis of 80 degrees. The next one's going to be 5. Cis of, what's 80 plus 120? What? K is 200. And I'm supposed to have 3 answers. Let's try one more time. What's 80 plus 2 220s or plus 240? Right? 80 plus 240? 320? If I was to go again, it'd be over 360. I'm done. These are the only answers that fit. And if I really wanted to, I suppose we could even graph them and say, well, 80 degrees would be here-ish, going out 5. 200 degrees would be here-ish, going out 5. 320 would be here-ish, going out 5. All right, kiddos. We made it. 65.
Nice.
How do I attempt it for tomorrow? Post a grade. Sound good?
That was nice last year.
Go get nutrition. Go get a break.
There is no break.
You debate, and love and grace. Bye.
You have Mrs. Cody now.
I love our culture and how it says.
She's gonna punish you.
Somebody decided to take the AP class, so that's.
Because I want to go to college with Thomas. It's not my
Great,
goal.
I'll take it next year.
No, I don't want to do lit because I just, no. I don't want to do that.
I love it.
Yeah, I know it's easy, but I'd rather just be good at writing than read books all the time. I don't have time to read. I barely have time to sleep. There's no time to read at that rate.
I have to make kind of like the AP not as much as Mrs. George's. Because she like gives the actual APs, but this is the actual APs for testing. So this is reading. I kind of give tests that are similar to how we do it here, multiple choice long answer, but the questions, the multiple choice answers are there to trick you because that's what the AP is. So the multiple choice questions are harder than this year. Otherwise, the content's just different, so it's hard to compare until we get to the final chapter this year, then it's being calculated and all this. But basically they're like formula cards where we compile all the important stuff and we memorize. So if memorizing is not too bad, you can get good points in those quizzes because it's just memorization. The problems, you just have to work on a little bit by a little bit. So if you always leave homework to the day before the test,
Bye, Carl.
people who like having to
Hi, can you hear?
yeah, once you said it, does that sound good? That's all.
Yeah. That's fine. Thank you. Ooh, I can. They
Yeah,
look
they
so
do.
good.
They did a good job. They were proud of them.
Yeah.
I'm proud of them too.
No, he'll probably just try you.